Thanks, Evan. All right. Is it still morning? It is. Just barely. All right. So the first one says d dx. All right. So when I look at that d dx, I'm taking the derivative. So this is the power rule. So what do I do with that -5? I move it to the front. Right? We're taking the derivative. Now, how do I figure out the new power when you're taking a derivative? You subtract 1. So what's -5 minus 1? -6. You did it. You're done. That's it. ddx means to take the derivative. An integral. We're going to go backwards. Well, we just practiced it. But I want to make sure we're good here, because if you can't do this, then you really shouldn't be doing this, right? If you can't take derivatives, you really shouldn't do antiderivatives. We slay? Okay, I know what that means, but sure. As long as you don't slay me, we're good, right? That means kill, right? No? Oh, see, man. Okay. The integral of x cubed dx. Is there a number in front? No. Remember, if there's a number in front, I always move it in front of the integral. Okay? So what I do here is I add 1 to the 3, which is 4. What's the reciprocal of that number that I just wrote? 1/4. And don't forget to put plus c.
You don't have to put times 1?
Don't have to put times 1? You talking about like because there was nothing in front? Yeah, you don't need to put that.
But is there a 1? Is it imaginary or there's no 1?
There is a 1 there, right? There's a 1 in front of everything that we have.
But you don't need to put it.
Nope.
Sorry.
No. Okay, hold on. Are you talking about d dx? Or are you talking about dx? Dx, I'm going to hold off on what the explanation is for that until January. My explanation right now for dx is that when you see this, it means take the antiderivative with regards to x, the variable x. That's all it means. So my answer should have an x. That's what I'm saying. In this case, yes. These are indefinite integrals, so it should have a c. Let's do number 3. Let's do number 3. Okay. Number 3 is d dx, which means take the derivative. All right, I'm going to use the power rule here. So I already have a 1/2, but I need to multiply by that power as it comes to the front. So I put the -3 next times x. And then how do I get that new power? Subtracting 1. So what's -3 minus 1? -4. So let's clean it up. So this is -3/2 x to the -4th power. That's it. That's it. Yeah. I mean, there's nothing else you can do.
Wait, why'd you take the 1/2 out?
I didn't take it out. It's got to multiply by whatever comes down from the power.
Well, can't you just multiply the 1 times -3 like right away?
Oh, for sure. I definitely would not show that step. I would just write the answer. But I just want to make sure everyone sees what I'm doing. Yeah, I definitely would be like, oh, a -3 times 1/2 is -3/2. Absolutely. Everybody good? Okay, last one. I chose this one for 2 reasons. The first reason, it has a 2 that's in front of the x, so I'm going to go ahead and write that in front. All right? So then what I'm going to do is I'm going to bring the 2 down, right? I know the 2's got to come be in my answer. And then I'm going to write my x. How do I find the new power? Add 1. So what's -3 plus 1? -2. Immediately when I write that, my brain thinks, what's the reciprocal of -2? It's -1/2. And you have that 2 in front as well. Do I need to do that again, Angel? No? Okay. So what's 2 times a half?
Negative 1.
Just 1, and so I have that negative. So this is the answer. You good, Georgie? Because when you ask for help on this, I'm going to say no. Okay. I figured you do. You probably do have it, but just in case.
Whenever you bring the x times x to the square minus negative square.
X to the negative second power?
Yeah. And then you don't have to bring down dx again?
No. So the idea is once you are going from this integral to writing the antiderivative, I don't write the dx anymore. That's why I'm going to finish with the plus c.